Let's talk about intermolecular forces. Intermolecular forces, the hidden forces that hold molecules together and shape the physical world around us. First of all, what are intermolecular forces? They are attractive forces between molecules, not within molecules. Unlike covalent or ionic bonds that holds atoms together inside a molecule, intermolecular forces work between the molecules. So they can impact to the boiling point, viscosity, melting point, and etc. Now let's break them down into four main types. The first type of intermolecular force is called London dispersion forces. These are the weakest, but they exist in all molecules, even noble gases. They occur due to temporary dipoles formed when electrons happen to be more on one side of a molecule than the other. The bigger the molecule, the stronger the dispersion force. I mean, the London dispersion force for argonium is more than the neonium due to the number of electrons. That's why the boiling temperature for argonium more than neonium. The second one is dipole-dipole interactions. These happen between the polar molecules where there is a permanent separation of charge. The positive end of the molecule is attracted to the negative end of another. For example, hydrochloric acid. As a result of the dipole-dipole interaction, the boiling temperature for hydrochloric acid will be more than the other compounds. The third one is hydrogen bonding. This is a special case of dipole-dipole. Hydrogen bonding occurs between the hydrogen and the fluorine, oxygen, or nitrogen, between these elements due to their electronegativities. The next one is ion dipole forces. These occur when an ion interacts with a polar molecule. Polar solvent may be the water. For example, the sodium chloride. When we dissolve the sodium chloride in water, as we know, the sodium chloride will dissociate into the ions. And this is an ion dipole interaction.